Alright, this is continuing section 11.7. I'm going to start another example page. This is on what we call complex numbers, and this is really where we use imaginary numbers, is with complex numbers. A number containing, whoops, spelled that wrong, containing a real value and an imaginary value is called a complex number. And this is easier than it sounds. It sounds weird, but it's pretty easy. The notation is A plus or minus B and then the letter I for imaginary. The A is what we call the real value, and the BI is what we call the imaginary value. And again, this is going to seem very strange, but if you think of it like 3 plus 2x, it's the same idea. We might have 3 plus 2i, or 4 minus 5i. It's the same idea as the variable, just with the letter I for imaginary numbers. So we're going to look at some operations with complex numbers. We're going to start with adding or subtracting. The rule for adding and subtracting is that the real can add or subtract with the real number, and the imaginary number can add or subtract with the other part that's imaginary. Oh, I did not like spelling. Let's try that again. Imaginary. And so for me, it's kind of like combining like terms, just like we do with variables. So if I have 2 plus 3i, and I want to add that to negative 3 plus 2i, if I want to add those two expressions together, the 2 can add with the negative 3 to make negative 1, and the positive 3i can add with the positive 2i to make positive 5i. So it's not as bad as it sounds. You add the integers together, you add the imaginary parts together. That's all it is. If I have 5i minus parentheses 2 minus I prefer to distribute that negative so I don't miss anything. So I would say that that is 5i minus 2 plus I, which the 5i can go with the plus 1i and get 6i minus 2. And we write the real number first and then the imaginary. So we're going to write negative 2 plus 6i. You always put the real number first and then the imaginary. So I think this is relatively easy. Let's do it a couple more times. We have negative 3 minus 7i minus negative 6. I would pause the video and try that one. And if we have 8 minus I minus 2 minus 3i. Again, pause the video here and try those two problems on your own, and then play the video to see if you got them correct. The top one is going to become negative 3 minus 7i plus 6, which makes 3 minus 7i. This, I like to distribute the negative, so that's going to give us 8 minus I minus 2 plus 3i. And that should give you 6 plus 2i. So the 8 and the negative 2 go together, the minus I and the plus 3i go together, You put the real number first and then the imaginary. So adding and subtracting is just combining like terms. Now let's look at multiplying. The thing to remember is that I squared is negative 1. That's very important. I squared is negative 1, just like we talked about, or I talked about in the last video. If you can remember that, multiplying is not so bad. So if I have negative 7i times 3i, that makes negative 21i squared. And remember that I squared is negative 1, so it's negative 21 times negative 1, which works out to positive 21. So this is very, very important. Anytime you see I squared, you immediately change that into negative 1. So if I have 3i times 5i, that's going to give me 15i squared, which is 15 times negative 1, which is negative 15. Let's try that a couple more times. If I have 3i times 2 minus I, or if I have 2i times 4 plus 9i. Both of these are distributing problems. If you feel comfortable, pause the video and try them yourself. If not, you can watch me. If I distribute, 3i times 2 is 6i, just like variables. 3i times negative I is negative 3i squared. Now remember, anytime I see I squared, I convert that into negative 1. So this becomes 6i minus 3 times negative 1, which becomes 6i plus 3. And we put the real number first and then the imaginary number. So it's 3 plus 6i. Oops. 3 plus 6i. If you feel comfortable, try the second one. Pause the video. If not, watch me. That's 8i plus 18i squared, which becomes 8i plus 18 times negative 1. So I squared immediately becomes negative 1. Same thing here. As soon as you see I squared, it becomes negative 1. This is going to give me 8i minus 18, and we write the real number first, and then the imaginary. So it's negative 18 plus 8i. So that's simple multiplying. Now we're going to get into binomial multiplication. I'm out of room, so I'm going to switch pages here. This is when you have to FOIL. Another example page. You might have a couple sets of example pages on these because they do take up a little bit of room. So FOIL, if we have 2 minus 5i times 4 plus I, we're going to FOIL this out. And you treat the i's just like variables. 2 times 4 is 8. 2 times I is positive 2i. Negative 5 times 4 is negative 20i. And negative 5i times positive I is negative 5i squared. Now we're going to clean this up. The 8 is just 8. Positive 2i can combine with negative 20i to make negative 18i. Minus 5, now as soon as I see I squared, I'm going to write negative 1. So it becomes negative 5 times negative 1. From here, that's 8 minus 18i plus 5, which gives me 13 minus 18i. Just combine the 8 with the 5. 13 minus 18i. Real number first and then imaginary. Okay, I'm going to let you try this one. So once I write it down, pause the video. 2 plus I, 1 plus 4i. Pause the video and try this, and then play it back to see if you got it correct. It's going to be 2 times 1 is 2. 2 times 4i is 8i. I times 1 is just I. I times 4i is positive 4i squared. This becomes 2 plus 9i plus 4 times negative 1, which is 2 plus 9i minus 4. So the final answer is negative 2 plus 9i. You treat the i's just like variables. You can combine like terms. Anytime you see I squared, you put negative 1. All right, let's try 2 minus I squared. Now when the squared is on the outside, it's very tempting to just square the first number, square the second number, and move on. But remember that this is actually 2 minus I times 2 minus I. It's very important to write it down like that so you don't mess this up. Then you have to FOIL. 2 times 2 is 4. 2 times negative I is minus 2I. Negative I times 2 is also minus 2I. Negative I times negative I is positive I squared. This becomes 4 minus 4I plus negative 1, or you can just write minus 1. So this is 4 minus 4I minus 1. So your final answer would be 3 minus 4I. So when you have a binomial squared, make sure to write it out and FOIL it out. Try it again. 3 plus 2I squared. Pause the video and try it on your own, and then play the video to see if you got it correct. This is going to be 3 plus 2I times 3 plus 2I. 3 times 3 is 9. 3 times 2I is 6I. 2I times 3 is also 6I. 2I times 2I is 4I squared. This becomes 9 plus 12I plus 4 times negative 1, which is 9 plus 12I minus 4, for a final answer of 5 plus 12I. 5 plus 12I. All right. A couple more, and then we will move on to division. So let's do 7 plus 3I times 7 minus 3I. If you feel comfortable, pause the video and FOIL it yourself. If not, you can watch me. 7 times 7 is going to give us 49. 7 times negative 3I is negative 21I. Positive 3I times 7 is positive 21I. Positive 3I times negative 3I is negative 9I squared. That's 49 minus 42I. Ooh, just kidding. Not minus 42I. Those two cancel themselves out. Sorry about that. Minus 21I and plus 21I go away. So there is no more I term. And then this is minus 9 times negative 1. So this becomes 49 plus 9, which is 58. If you notice, there's no more I term. It's no longer a complex number. It's just a real number. So when you have, this is called the conjugate, 1 plus and 1 minus, those middle two terms cancel out. I squared becomes negative 1, and you no longer have an imaginary number. That's going to come in handy when we're dividing. Let's try one more. Radical 3 minus 2I times radical 3 plus 2I. Now don't panic because of the radicals. You know how to work with these. Radical 3 times radical 3 is just 3. Radical 3 times 2i is 2i radical 3, radical last. Negative 2i times radical 3 is negative 2i radical 3. And negative 2i times positive 2i is negative 4i squared. Now look what happens. The positive 2i radical 3 and the negative 2i radical 3 go away, which is quite nice. Gone. That's what happens when you have a conjugate. Those middle terms cancel. So what we're left with is 3 minus 4, and then I squared is negative 1. This becomes 3 plus 4, and it's just 7. No longer radicals, no longer imaginary. And that comes in very handy for dividing. Alright, so last but not least, we've added, subtracted, and multiplied, and now we're going to divide complex numbers. And I keep switching pages. You might not need so many pages. This is going to be another example page for me. Alright. So what you're going to do is multiply the top and the bottom by what they call the complex conjugate. It's just like we did with radicals. Complex. They just call it complex because it's imaginary. Conjugate. Complex conjugate. So I'm just going to jump right in here. This should make sense. If I have 6 over 2 plus 3i, what we're going to do, just like we did with radicals, since we cannot have the I on the denominator, we're going to take that and multiply by the conjugate 2 minus 3i over 2 minus 3i. So when we multiply by the conjugate, we'll work out the numerator. 6 times 2 and 6 times negative 3i. It's going to give us 12 minus 18i. Remember, on the denominator, we can skip the middle. We can do 2 times 2, which is 4. And positive 3i times negative 3i is negative 9i squared. Remember, we get to skip the middle because there's 1 plus and 1 minus. What that gives us is 12 minus 18i over 4 minus 9, and I squared becomes negative 1. So my final answer is 12 minus 18i over, this becomes 4 plus 9, which is 13. So the final answer is 12 minus 18i on the numerator over 13 on the denominator. So it's just like we did with radicals, multiply by the complex conjugate, and then you get to skip the middle. Let's try that again. 5 over 1 minus I. I recommend pausing the video and trying this on your own. If you're not comfortable yet, you can watch me. We're going to take the denominator and multiply by the conjugate 1 plus I over 1 plus I. We're doing that on purpose to make sure that there's no longer imaginary numbers on the denominator. So we're going to have 5 times 1 and 5 times I, 5 plus 5i over, when we do this we get to skip the middle. 1 times 1 is 1, negative I times positive I is negative I squared. This becomes 5 plus 5i over 1 minus negative 1. So the final answer is 5 plus 5i over 1 plus 1, which is 2. 5 plus 5i over 2. One thing I need to mention so that your homework doesn't get mad at you. The homework wants you to separate this into 12 over 13 minus 18i over 13. So you split the denominator between the two. So it's going to want you to split this as well. 5 over 2 plus 5i over 2. It wants the real separated from the imaginary. So in my math lab, you will need to enter them separately. On your exam, I'm okay if you leave it like this, but technically you put the real and then the imaginary. Alright, let's try this a couple more times. The video might cut me off. It automatically stops at about 25 or 26 minutes, so if it cuts me off, I do apologize. This is 3 plus 2i over 4 minus 3i. Same idea. We multiply by the conjugate of the denominator. So we're going to multiply by 4 plus 3i over 4 plus 3i. And I always put parentheses around everybody. Now on the top, we're going to have to FOIL, because we have 2 terms times 2 terms. This is going to give me 12 plus 9i plus 8i plus 6i squared. On the denominator, I get to skip the middle, so it's just going to be 16 minus 9i squared. So on the top, I'm going to get 12 plus 17i plus 6 times negative 1. On the bottom, I'm going to get 16 minus 9 times negative 1. So every time I see I squared, I switch it to a negative 1. This gives me a final answer. This is going to become minus 6, so it becomes 6 plus 17i, and I got that from doing 12 minus 6. On the denominator, I'm going to have, this is going to become 16 plus 9, which is 25. And that's the answer that I'm okay with. MyMathLab is going to want you to separate that into 6 over 25 plus 17i over 25. So MyMathLab wants 2 separate pieces. Alright, the video has about 3 minutes left. I'm going to try to show you this last example, 2 plus I over 1 minus I. If you'd like to pause the video and try it yourself, you're more than welcome to. Otherwise, you can watch me. I'm going to go a little bit quicker so it doesn't cut me off. So I'm going to multiply by the conjugate, 1 plus I over 1 plus I. I'm going to have to FOIL on the top. This is going to give me 2 plus 2i plus I plus I squared over, I can skip the middle, 1 minus I squared on the bottom. This is going to give me 2 plus 3i minus 1 over 1 minus negative 1. So my final answer would be 1 plus 3i over 2. I know I did that kind of quick. The 2 and the negative 1 go together, and this becomes 1 plus 1. From there, MyMathLab wants you to separate that into 1 over 2. So this is from MyMathLab. 1 over 2 plus 3i over 2. So this is how they want the final answer in MyMathLab. Alright, have about a minute to spare. We did all the operations with complex numbers. I think it's pretty straightforward if you treat them like variables, and if you can remember that I squared always becomes negative 1.